We're going to talk about consciousness now. Consciousness is the fundamental reality. Larger consciousness system is a digital information system. The most fundamental level, consciousness is information. The most fundamental level, information is bits. And at the most fundamental level, bits are binary. So I'm just taking the simplest case in each of these things. So information is non-physical and subjective. Thus consciousness is non-physical and subjective. Now you're thinking, how is it that information is non-physical? We deal with information in physical form all the time, but not really information that we're dealing with. What we're dealing with is the media. Okay, we have a book. The book, the paper, is the media. The ink in it that make the words, the ink squiggles inside, they're the code symbols. Both of those are obviously physical, but neither of those is the information. It takes a consciousness to interpret that information. Okay? The information is stored in that physical form and can be transmitted in that physical form, but it takes a consciousness to put it there and a consciousness to retrieve it. Information is non-physical. Okay? You can't put information in a bottle. You can't weigh information. If it doesn't have mass, it's not physical. If it doesn't have volume, it's not physical. You can weigh a book, you can weigh ink, you can weigh paper, but information has no weight, has no volume, it's non-physical. Okay? So it's also subjective. When we look at information, what we get out of that information may or may not be what the person that created it intended, right? We get out of it based on what's inside us, our own history, our own experience. That's what allows us to interpret that information. So the interpretation is personal. It's our own. So all of that information we get is all personal information. It's all subjective information. Okay, information's the meaning, the content, the message, not the media, the code symbols. Now we're going to talk about evolution. I have a couple of points on this slide that I want to make about free will as well. Information in digital systems is represented by organized bits. Information systems have entropy. If you're in the information sciences, you'll understand that term. Entropy is a physics term. It first started in thermodynamics. It's a measure of order. Okay, if you have a lot of order, you have low entropy. You have a lot of disorder, you have randomness, you have high entropy. Also, if you have a high entropy, you don't have much ability to do anything. If you have low entropy, you have more of a capacity to do work. Now, that's just the physics terms, said simple. And the reason that works that way is that if you have, if you have an automobile and your automobile is taken apart in every piece part, every washer, every nut, every bolt, every scrap of metal is laid out, on the ground. That's high entropy, right? You got all your pieces now are not relating to each other the way they were. Or if you take all those pieces and put them together such that each piece has a very specific relation to the next piece, which has relation to the next piece. There's a lot of order there, right? To get all those pieces ordered just exactly properly, then you can get in your automobile and turn it on and drive away. It can do something. So you can see this relationship between ability to do work and entropy. High entropy, if everything's random, then it doesn't really have ability to do anything. It can't carry any information, it can't do anything. It's just random nothingness. Okay, so that's what entropy is. Now, all information systems have entropy. In information science, if you have a random field, and then if you want to put information in that field, you have to lower the entropy. You have to put something non-random. No information can be carried. So you have a bunch of children's blocks, and they're thrown randomly on the floor. There's no information there. But if you take those blocks and you spell something with them, now you have information, right? You spell C-A-T with the blocks, you got a cat. Or you can take the blocks, it's not all words, it's patterns. Take a block up, a block down, a block up, a block down. What's next? A block up, right? Why? Because there was a pattern. So there's information in the pattern because you were able to predict where the next one was going. So information can be in all sorts of things besides, words. We think of information in terms of words, but it's bigger than that. Self-changing systems with a purpose evolve to be more successful within their environments. Okay, that's just a general thing. Evolution exists. You have a self-changing system. It's a system that can self-modify. If it's a purpose, so it knows what it wants to self-modify toward, then it will modify itself toward meeting that purpose. Now, in our physical evolution, what was that purpose? Survival and procreation, right? Those were the criteria which we evolved to those criteria. Within information systems, information's non-physical. Information doesn't have to eat and it doesn't have to procreate. So what's its criteria? Entropy. Information systems evolve by lowering their entropy. Lower entropy in information means more information, more content, right? More meaning, more significance. So that's how they evolve, by lowering their entropy. All right, I'm going to talk about free will for just a minute here because it comes out of this third bullet. First, I want to tell you about decision space. Decision space is a term I coined, and it means those things that you have, those choices that you have to make a decision. Okay, so something happens to you, and you have to react to it. You have to do something. That's what I'm calling the decision. It's your choices, the choices that you have. So somebody comes up and kicks you or nudges you or does something you don't like, insults you. You have choices. You can get mad. You can get violent. You can say you're sorry and leave. You can, try to find out what the problem was. You can try to conversation. You have all kinds of choices of things that you can do. And some of those choices don't involve getting angry. Some of them involve, other ways of dealing with the process. So you've got choices. Now you may know, if you sat down and listed all the possible choices you'd have in any particular event, you would have some finite number, right? Let's say there's 10. Now, if you have 10 choices that you could make, you say, well, here's the 10 basic choices I could make at this time. There's probably more choices that you could make that you don't know about. They're outside of your reality. They're outside of your belief space. And if that's the case, they're over here. You may have done those, but they never come up. They're not in your awareness. So it doesn't have to be, your decision space isn't all possible choices. It's just those choices that are in your awareness, choices that you can make. It's not that big it's a subset of all the choices. Now, what is free will? Free will is your ability to choose one of those choices out of your decision space. That's all. Okay, free will is not that you get whatever you want. Free will, some people say, well, I obviously don't have free will or I'd be rich, famous and good looking. And say, well, that's not what free will is all about. It's not that free will allows you to freely choose to be anything you want. Free will says you have a decision space. That decision space is limited. It's limited based on your own, education, your environment, all sorts of things. If you do something bad and you get thrown in jail, your decision space just shrunk as far as your ability to go home, right? They won't let you do that. So decision spaces can grow and they can shrink. The size of your decision space is generally proportional to the size of your reality. Your reality can grow and shrink. People with small realities, very small realities. What kind of people are those generally? Depressed, suicidal. They have very small realities. The only thing in that reality is all that bad stuff that I can't stand and it isn't worth living for. All these other possibilities that might be wonderful, can't see those. They're not in their reality. Very small decision space. Someone who has a very large decision space is one who, kind of lives in the moment, lives in the larger reality all the time. So everyone has their own amount of decision space. So that's what free will is. It's just simply an ability to choose among the available decisions that you know about, nothing else. Sometimes people say, well, if it's a computed reality, doesn't the fact that it's computed lead to determinism? And no, of course not. There's plenty of practical randomness in the system. Plenty of practical randomness in the system to produce sufficient choices for, all we need is enough choices that we have several choices to make, and we have a free will to make this one as opposed to that one. And we have lots of choices. Almost everything we do, there's plenty of different ways that we can react to things. So that's all really that's required is some different ways that we can act, and we get to choose which way it is. All right, maybe I'd make one other comment. I don't have the time to derive it for you, but consciousness and free will are logically necessary for each other. You can't have consciousness without free will. If there's no choice to be made, you know, what's the consciousness doing? The consciousness is your awareness. You make choices. If there's no consciousness, there's no free will. If there's no free will, there's no consciousness. They are both aspects. It's like a head and tails on a coin. They come together. And I have a long derivation of that. If you want the details, it's in chapter maybe 11 in book 2, maybe. Attributes of consciousness. Okay, it's a real, finite, large, complex, self-modifying information system where stasis is unstable. Big, complex systems never just stay the same. You know, eventually, they go one way or the other. They either evolve or they're going to de-evolve over a long period of time. So in the long run, you either evolve or de-evolve. So if you happen to be a self-aware digital information system and you evolve by lowering your entropy, then it's either evolve or die, right? You evolve or de-evolve. So I guess that's the way in the physical reality too, for your procreation and survival. You know, you either evolve or you become somebody else's lunch, right? You succumb to your environment if you don't evolve. As the environment changes, you have to be able to evolve, or you fail as an individual first, and then enough individuals as a species to do it. So it's in an information system, it's even you have just that one thing, entropy. So there's fewer degrees of freedom. Evolve or die. Love is the nature of a low entropy consciousness. Now, that seems to just jump out of nowhere, right? How do I make that connection that love is the nature of a low entropy consciousness? Well, you have to have the idea that digital information system that is conscious is about communications, right? What else would an information system do but communicate, right? I mean, it's about communications. It's about interaction, relationship between subsets of consciousness. Well, so that's a fundamental thing it does. Communicates, interrelates, interacts. Why? So that it can lower its entropy and evolve and not die. Okay, so that's what it's about. Then love, which is the opposite of fear, and ego and hate, and those things are all subsets of fear. So we have love optimizes positive communication. Love optimizes interaction. It optimizes relationships, right? And take the opposite. Fear, ego, isolates, inhibits, fractures, right? It's not positive for communication, interaction, and relationship. It raises system energy. And a little example, take two systems. We make two hypothetical systems now. Each one of them are going to give 10,000 people in each system. Okay, system A, we're going to call utopia. And system B, we're going to call hell. So system A and utopia, we have 10,000 people, and basically the people that we're putting in both of these are the same, right? Same 10,000, right? So that's not different as far as their capabilities, you know, their intelligence, you know, what they know and that kind of stuff. But there is going to be a basic difference between them. In utopia, everyone is loving. Everyone cares about other. Caring, mutually supportive, cooperative, trusting, helping, building. The whole takes precedence over the self. Everyone looks out and helps everyone else. Building, constructive. There are no loafers. There are no abusers. Like one big, loving, caring, supportive family, right? Where everyone works hard and contributes as much as they can, okay? That's the way it is in A. You know, in the old days, somebody's barn burns down and all the neighbors come by and help him build the barn again, right? Okay, because why? Well, because it's a neighbor and they can do that. All together, they can make it work. So they work as teams. Somebody comes up with a new invention, a new good idea how to do something better, shares it with everybody else, and now they all do it better. Okay, now we go to hell. Hell, everyone's full of fear. It's about self, me at the expense of others, self-centered, no trust. Why help or cooperate? What's in it for me? Competitive, demean, debilitate if you cannot eliminate your competition. Trick, manipulate, control, dominate, and use others to satisfy your own needs. Violence and power is the final arbiter of disputes. Law of the jungle, the strong take advantage of the weak. Eventually, what happens? 3% of the population owns 95% of the wealth. Most of the people are poor, overworked, miserable, dysfunctional. In fact, even that 3% at the top of the pyramid is mostly miserable and dysfunctional as well. Love and trust is for fools and masochists, right? That's hell. Okay, and what about utopia? How do they end up? Well, they end up optimizing whatever they have, whatever they can do together. They end up optimizing the resources that are put in, same resources are put in each one, A and B. They end up optimizing their resources. Everybody, gets some sort of, they have some way of working out who gets what and so on, but they're all working together. So if you have these two systems, hell sounds familiar, doesn't it? We can all imagine where that place is. We've kind of live in one like that. But so that gives you an idea of why I can say that love is the nature of a low entropy consciousness. So those low entropy things, love, caring, supportive. If you're talking about relationship and communication and interaction, then obviously love, you see, is a low entropy consciousness. Those two things go together. So what we say then, if you have consciousness and it evolves to be very low entropy, it evolves to not become loving, but to become love. That's what love is. That's the definition of love. It's low entropy consciousness. And now we've got love as a technical definition in terms of entropy. Isn't that neat? Okay, something a physicist would like to do. Now, let's go on to, just going to give you a quick summary of where we are with consciousness. It's best modeled as a superset, a self-modifying digital information system capable of computing virtual realities, right? Consciousness computes the virtual reality. It is other. It's the computer. Larger consciousness system evolves by lowering the entropy of the system. It lowers the entropy of the system by organizing the bits at its disposal in more profitable configuration. Content creation, reorganization opportunities are generated by using conscious intent to apply free will choice to incoming experience data. Okay, feedback of the results, previous choices allow us to modify future choices. That's the fact that you have choice at all means you have free will. No free will, no choice. No choice, no change. No change, no point. It's a dead end. Okay, next we're going to go to where do you and I come from? What about us, we people? Because experience is a generator of input, consciousness facilitates its own evolution by creating many smaller units of consciousness and setting them loose to evolve, lower their entropy by interacting with free will. Okay, that's us. Okay, what happens is this larger consciousness system is just a monolithic consciousness, one big unit of consciousness. So it needs to evolve and lower its entropy. It can only interact with itself. The way you grow up in consciousness, the way you become love, the way you lower your entropy is through interaction. You need experience. You need to be able to interact and make good choices, and those good choices move you toward becoming love or move you toward becoming fear. So the way to do that then is to, just like in biological evolution, we have cells that found out it was actually lowered their entropy as well by increasing their organization by splitting into multiple-celled beings. Instead of single-celled beings, there were multiple-celled beings. And after a few million years of multiple-celled beings, they had specialized cells. So you had the part that would eat, and the part that would run, and the part that would bite. And you had all the different parts that specialized in things. And that all became more survivable, became more adaptable. It became more organized. It was lower entropy. You see, even the entropy definition works even in biological evolution. All evolution really works by lowering entropy. So you get more complex, more organization, more ability to do things, more ability to adapt, and you That's how you evolve. Okay, so this consciousness system found that it could evolve, it could increase its organization, it could increase its information by breaking itself into pieces, just like, by multi-celled, having a multi-celled being rather than a single-celled being. And then there was specialization and so on. So you can think of it growing up the same way. So here we are. We are these independent units of consciousness that were created to interact with each other. And in that interaction, they make choices. And in those choices, they either evolve by making good choices that make them move closer to love, and they make bad choices that make them move closer to fear, and that's de-evolve. The whole system wants to evolve, right? Or it's evolve or die. So now we have a system that's all these independent parts that are hopefully each lowering their entropy a little bit at a time, and as they lower their entropy, the system lowers its entropy because they are the system, and the system is them. All right, so that's where we come from. All right. Now, where does the physical reality come from? Physical reality comes from constraint. Why constraint? Constraints provide structure and allow for choice. If there's no constraints, there's no way to base an interaction. It's hard to learn from an interaction. Imagine yourself on the internet and you're in a chat room, and you're in a chat room with 10,000 other people, and in this chat room there are absolutely no rules, no etiquette, no anything. In other words, anybody can say anything to anyone at any time for any reason, and every time you come into this chat room, you can make up a new name. Okay? You make up a new name every time you come in. Well, what good is it, right? I mean, there's no information there. You can't depend on anything. Even if you had a nice conversation with Charlie, next time you come in, somebody else could call themselves Charlie. And also, if we say that in this chat room, everybody, if they want, can listen in on anybody else's conversation. There's no real privacy either. So what good would it be? You see, there's nothing you can do there. There's no traction. There's really nothing you can learn. Everything is suspect. Everything is, well, you need rules. Rules are what give you ability to have strategy. Rules are what give you this constraints of choice. When there are no rules, there's really no learning. Sometimes I do the analogy, what if we were all playing a game? And there's this game. And I said, okay, we're going to play a game. Go. And you say, wait a minute, what are the rules? I say, oh, there are no rules. We're just playing a game. You see? Wouldn't be much fun, would it? The only thing that makes a game interesting are the constraints. It's the rules, it's what you can't do. You have to, here's the things, you're limited to these sets of actions. Once you're limited and you have those constraints, now there's strategy of how you can manipulate what it is you can do in order to win or in order to do whatever it is the game's about, you see. So that's why you need constraints. So here's this big conscious system. Now it's broken itself into lots of pieces, but there's no traction there. It needs something to make this evolution more efficient because it's evolve and die. It wants to make the evolution more efficient. What does it do? It creates some constraints. It creates virtual realities. Virtual realities are a place that have rule sets. We live in this virtual reality and has a rule set. What's the rule set? It's science. You drop something, it falls down. It's part of the rule set. How did this reality get here? People have an idea that it got here the same way as, say, World of Warcraft or The Sims. Some programmer sat down and designed it. It isn't that way. It evolved. This virtual reality evolved. How does it evolve? The big digital bang. How else? So you have a computer. You start off with some initial conditions, some rules, like Maxwell's equations and, basic physics, how things expand, gravitation, that kind of stuff, heat, temperature. You define some things, give it some initial conditions, and then you hit the run button. That's the big digital bang when you hit the run button, right? And it starts to run, and what happens? You have all that stuff. You have a lot of energy in a tight ball, high pressure, high temperature. This is the way your simulation starts. Those are your initial conditions, and it expands, and as it expands, gases come together, and they congeal, and you get planets and suns, and then eventually you get a place like this, and then you get little cells, and and here we are. So the whole virtual reality wasn't programmed, it evolved. It's still evolving, just like it's still physically evolving. It's still evolving, and it's being computed. That's what we mean by virtual reality. Okay, now, what did it evolve? It evolved constraints. You can only do certain things here. Okay, you can't jump 20 feet in the air. Bodies weren't made that way. They're too heavy and the legs are too small to jump 20, 30 feet in the air. Some critters can jump 10 times their height. We're not one of them. Why? Because the constraints of this rule set, as it evolved, says we're like this. That's the way we evolved, and we can't do that. So we have constraints. We can't learn integral equations and vector analysis in 10 minutes. Why? Because our brains didn't evolve to be able to do that. So we are who we are. We interact in this reality based upon constraints that we have based on the rule set that evolved this. That's how this virtual reality gets here. So now what are we? We're consciousness, right? So we're consciousness, and we're involved in this virtual reality. How is that? Well, we get a data stream. Data stream comes, we interpret the data. We interpret the data as this reality. That's what it means to be a virtual reality. If you look at the Sims, what are they? They're data streams, right? Data streams. And they make little pictures on screens, and we interpret that reality. How do we get so clever at interpreting data to be this reality? That's what we do when we're born. You look at a little infant, and they're lying there in their cradle, and arms are going this way and that, and feet. They don't know even that arm's attached to them. Eventually it comes up here and they learn, oh, that's mine. I can make it move, and that's a discovery. Well, that's how they're learning to interpret the data. This is the data. They see something, okay? They interpret, or they're getting the data stream that something's there, and they interpret that data. Well, they learn eventually to get the data and interpret it as this reality. If they grew up in a very different reality, they interpret it as that reality. See, that's what you do. So that's how the virtual reality works, and that's why it's there. It's there as a set of constraints to produce a learning lab, if you will, for these individuated units of consciousness to interact with each other with constraints so that we can play the game effectively. So we have choices within these constraints. We have feedback within the system. You can't learn with no feedback. You can't learn if things aren't consistent. You wouldn't send your kids to a school where every day, the teacher was different, the room was different, and the lessons were different. They would just be confused all the time. You need consistency. So you need a very constrained virtual reality. So that's why the virtual reality is here. So we got the consciousness system. Actually, if you've noticed, we only have really two assumptions in all of this. One assumption is that consciousness exists. We start with a consciousness system. And the other one is that evolution exists. Evolution is just a process that self-changing systems undergo naturally. And you have those two, everything else falls out logically. So that's a little hand waving here and there in the middle, but basically it all follows out kind of logically with a minimum of conjecture. It's all a logical process after that. So just two, that's pretty good if you only have two assumptions on your theory. So I'll talk just a second about brains because everybody worries about brains. The brain, just like the rest of your body, is virtual. You have a virtual body because you're interpreting it from the data you get, and that virtual body has a virtual brain in it. And where did the virtual brain came in? Well, it evolved. It evolved with that body, right, through that simulation that evolved to be us. It was all part of a simulation. So here you have a virtual brain and a virtual body. That virtual brain does the same thing as the body. It provides constraints. You can't do anything that your body or your brain can't form within this rule set. It can't accomplish within this rule set, then you can't do it. Now here you are with this virtual brain, and somebody hits you over the head with a lead pipe, and it bashes your brain, and now you have brain damage. Well, according to the rule set, you just got more constraints on what you could or could not do with that brain, right? So now maybe you can't think as well, or maybe you are paralyzed on one side of your body or something. Constraints just went up because the rule set says that if that part of your brain's damaged, then you have a dysfunction. So it's just a virtual brain. and a virtual body in a virtual reality. So it's not that we are physical creatures hallucinating a consciousness, as most scientists would let you believe. We are consciousness hallucinating a physical system. You have to think it just the other way around. All right. Now we're going to jump into virtual reality. How does it work? Multiple virtual realities. Virtual means informational, computed, right? So virtual reality is relative to the actual reality where the computation's being done. Okay. And that's kind of an interesting thing. I guess I moved that last one so fast, I'll take a little aside here that's interesting. How would you know that you're in a virtual reality? What test? Okay, here we are in a virtual reality. Is there a test that you can perform that you know you're in a virtual reality? Well, there's one major test that you can perform. If you're in a virtual reality, if you go back to the very beginning of that reality, you'll end up with not being able to go any further. In other words, you'll end up with a blank spot back there. It just started out of nothing, because it really did. Somebody pushed a run button in the computer room and it started. It didn't have to have a cause from this reality. It had a cause from some other reality, you see? So in this reality, there is no cause. It just starts. That's the view from the inside the virtual reality. Outside the virtual reality, somebody punched a run button, but that's in a different reality system, isn't it? You can't punch your own run button. It doesn't work like that. You know, you can't, you know, you have cause and effect. You can't do both. So the cause can't cause its own cause. You can't self-generate. You have to, something has to cause the effect. So in any case, that's what we have, of course, in the Big Bang, right? In the Big Bang, you get right up to the Big Bang, and they say, well, here's where our universe started. Had all this energy, all this, you know, high temperature, high pressure, a lot of energy, and the Big Bang started. It went bang, and it all expanded, and here's our universe. Well, before it expanded, there was no universe. So it certainly couldn't be anything in our universe that caused it, could it? That would be causing itself. You know, a program doesn't write itself. So in any case, it has to initiate from outside our reality, and it just starts, and there's nothing before it. That is the fundamental sign of a virtual reality. That's the way all virtual realities are. You get back to the origin, and there's nothing there. It just started out of nothing. Okay, it looks like it's, you know, it's a metaphysical start. Okay, it means it started in another reality frame. All right, so that's kind of interesting. Consciousness is the only thing that's fundamental. All other reality frames are virtual. All experiential realities are virtual. An experiential reality is a reality in which you, as a separate being, experience and interact with a multitude of other separate things and beings, where interaction appears to be more than just abstract data. This is a virtual reality. Virtual realities, dreams, this reality, out of body. Remember, if you have read Bob Monroe's books, he talked about locales, locale 1, locale 2. You know, these are all virtual realities. Where you end up after you die here, that's another virtual reality. There's other physical realities. There's other realities like this one, but it's not this one, that evolved similar to this. They have constraints, and it's another learning lab. Speaking of learning labs, I didn't mention that, but this is not graduate school. This particular learning lab is more like daycare. Okay? It's a place for budding individuated units of consciousness. And how do you know that? Well, if the consciousness system evolves toward love, and if you had a very advanced schoolhouse, and you turned on the television and watched the news, it wouldn't look like our news, would it? No. So you know we must be in daycare. Because what you see is what we are. If you look at the news and you look at how it is in our world, that's what we are. That's a reflection of us, you see. So in many ways you create your own reality, and I'm going to get into that some later. All right. Now, here are some of the mechanics of how virtual reality works, and then we'll hinge on these mechanics to show some of the artifacts of a virtual reality, and then we'll get back into seeing that the big world, macro world, looks just like the micro world as far as like the double slit. Same sort of thing works here in this larger world. Okay, there's actually one big data system that we squeeze through time, but I'm going to talk about it in terms of 3 different systems of data, 3 different databases, because it's just easier to understand if you break it in pieces. Let's start with now, the present. Okay, there is a present moment. Present moment is where all the free will gets acted. That's where we act. That's where we do whatever we do. Make our decisions is in the present moment. That's the only place we do it. So if you were this larger consciousness system and you had this virtual reality and then you had data streams coming from this virtual reality to all the players so that they could interact, that is like World of Warcraft, isn't it, Sims? You have data streams going down to each of the players and each of the people out there on their computers, all getting their own data stream over the net. They interact, multiplayer game. It's a very similar sort of thing. Well, it would be really handy if you knew what was coming next. Because if you knew what was coming next, you could get ready for it. You could prepare for it. You could have the calculations done and whatever. So it's very interesting. There's a lot of uses for knowing what's going to come next. So what happens in this larger consciousness system is it is a virtual reality, and it wants to know what is going to happen next. So it says, well, present trends continue. I can make a guess at what's going to happen next, because next is only 10 to the minus 44 seconds from now. It's not it's not too hard to guess that small a distance. So we can say, we'll guess that, and based on everything we know, of course we know a lot. This database now knows everything. It knows all the people in it, knows every thought, every emotion, every act, every intent, all the interactions. It's got all the history from the beginning, and you're not that unpredictable. So it can kind of say, all right, here's the next delta t. A simulation runs with an outer time loop. Delta t goes by, see another delta t goes by, and that's how time moves in the simulation in a computed virtual reality. That's the way time moves on. So it says, what's it probably going to be like the next delta t? All right, it's going to probably be like this. Now, assuming that's correct, what's it probably going to be like the next delta t? And assuming that's correct, what's it going to be like? And it goes on out as far as it can. Of course, errors compound as they go out, because any error made, then those errors flow on out, create more errors. So you can only go out so far before your predictions are just silly. But you can go out a pretty long ways on some things. Well, that's called the Future Probable Reality Database. So our consciousness system does that for us. It produces that. So then you have the present. Now, as time goes by, as this outer loop goes through its delta t's, what was, say, the very next delta t becomes the present, and then the next delta t after that, it becomes the past, right? So you have this whole database kind of flowing through the present, going into the past, and you had, I guess I didn't say this as well as I should, that probable future database is basically everything that could possibly happen, all of the possibilities, and the probability that it would happen. So it's all the possibilities with the probability that it happens. So then as that moves into the past, you have everything that could have happened, right? And the probability that it could have happened. Well, that breaks into 2 pieces. It's everything that could have happened and did. That's what we call our history thread. That's the line through that database that's just the choices we did make. Everything, it's all the things that could have happened, but here's what did happen. So that's just a string through that past database. The rest of it then is everything that could have happened but didn't. Okay, that's the past, unactualized database. So you can think of these. It's really just one big database that went from the future down into the past, but think of it as 3. The future probable, the past actualized, and the past unactualized, because that's just more convenient for us to break it into those pieces. All right, so these are the 3 big databases. Now in the Hindu theology, that's called the Akashic Records. It's basically all the information. Okay, that's all the information from beginning of time of this virtual reality. for all the people and critters and things, everything that's conscious. Okay, so another point is that free will works only in the present, right? So all of that data then that goes into the history, all the things, all of our past, the beings there, beings, and I put that in quotes, don't have free will. That's not, free will's not being acted out there. That's just the database. Okay, so what's there? Well, there's a model of you there. What's that model of you? It's the same model of you that's, thinks you're in this body, minus the free will. All the information, all the feelings, all the whatever, all the love, all the anger, all the facts, it's all there. But there's no free will because you don't have free will in the database. You only have free will at the present. All right. Nature of a virtual reality. This reality works a whole lot like The Sims or World of Warcraft or any of the other realities that your children play. I'm sure none of you play those, but your children probably do. In any case, it works very much the same way. So if you were playing World of Warcraft and your lizard man fell in the water and you didn't know how to make him swim, what would happen to your lizard man? He would drown. Why would he drown? Well, because he needs oxygen. So he'd drown for lack of oxygen. But is there oxygen? Do you need to render oxygen in a World of Warcraft game? Of course not. There's no different here. Do you need to render oxygen in this room? Of course not. You only need to render the effects of oxygen. The effects of oxygen are rendered here based on probability. Why do we not fall over from asphyxiation if no oxygen is rendered in this room? Rendering is just an individual data stream to each person. There's no need to render oxygen to you right now. You're sitting here listening to me. You're not looking through a microscope at oxygen. So no oxygen needs to be rendered. Why do we continue to breathe and exist? Because it's probable that we should. Why is it probable? Because there's enough trees, there's enough plankton in the ocean, there's enough things that says the probability that there's oxygen in this room is high enough that here we are, we're breathing. So we're only breathing based on a probability. It's probable that we would be, therefore we are. Only the result needs to be rendered. All the detail doesn't have to be rendered. So there's no oxygen molecules anywhere around here. Why would there be? Why would any of them be rendered around here? But the effects of them are being rendered, just like the effects of them are rendered when that lizard man dies underwater because he can't breathe oxygen. You see, it's a very similar kind of thing. So that reduces the requirements for making this virtual reality, right? We don't really have to render all the subatomic detail and all the rest of that. All you have to render is effects. So do we have brains in our heads? Not unless somebody cuts our skull open and looks, and then they'd have to render a brain. But otherwise, no brain needs to be rendered. Right? But we act as if we had brains most of the time. We act as if we had them. And how do we know how to act as if we had them? Because we're just abiding by a rule set that evolved this reality frame and evolved us as beings, computed us, and we evolved to have arms and legs that do what they do and a brain that does what it does, and we're committed to having to deal with those constraints. So we get the data set that embodies those constraints. See? Weird, isn't it? But this is the way virtual reality works. I like this one. I do it in all. If you watch my videos, you'll know what's coming in this one. If a tree falls in the woods and there's nobody there to hear it, does it make a sound? You've all heard that, right? Well, the answer, here's the definitive answer to that. There is no tree. There's no woods. There's no listener because they're all virtual, statistical, and probable. Here's the before picture. A person, walks into a woods. Nobody's been in that woods, some virgin woods. And this guy walks up to the woods. He walks in, and he sees a tree. It's dead. It's wobbling, but it's still standing up. So he takes note of that. He may even take a picture of it if he wants. He particularly notes that tree. He walks out of the woods, goes somewhere else, comes back 5 years later, walks into the woods again, same place, looks, and he sees a tree lying on the ground. Okay, now you're thinking, well, it fell over in 5 years. No. Why did he see the tree standing? Because when he walked into that woods it was probable that a tree would have been there. Not necessary. It went through all the possibilities and what was probable, and you go in then to a random draw out of that distribution of what's probable. And that random draw just happened to plant a wobbly dead tree in that spot. He comes back 5 years later, he looks at the same place, and what happens? It goes into another probability distribution now after storms and rain and wind and so on that have happened, that probably would have happened in that 5 years, right? And it renders that tree lying down. So the tree was standing up when he first looked, and the second look, the tree was rendered laying down. The tree didn't have to fall. Why? There is no tree. It's a virtual tree. Objective trees have to fall. Virtual trees don't. They just rendered this way, rendered that way. Works fine. You see how this virtual reality works? It's very strange. It's kind of weird, but if you play video games, it'll seem more natural to you. So these are things you have to notice. Well, okay, let's say that the guy sees the dead tree wobbling, he walks out of the woods, and then he wants to check to make sure it's still there. He runs back into the woods. Is it still going to be there? Yes. Why? Once it's rendered into this reality, consistency says it stays into this reality, just like the double slit experiment. Once you have an electron going through a slit and you know it's there, it has to remain a particle. Once that is part of our reality and the information's here, it has to stay that way. But now let's say that he comes back out of the woods, and as soon as he walks out of the woods, a bear eats him. One gulp, he's gone. Somebody else walks into the woods just a minute later. Bear ate him and ran off. And does that person have to see the dead tree? No. Why not? We just had an erasure experiment. Okay? There's no information now that says there's a tree there. So what does that person do? When that second person walks in, it goes into the probability, say, what's probable that he would see? Pulls out a probability. There may or may not be a dead tree there. Now, before it was probable, so it came out, but you know, what you're going to see in the woods could be any number of configurations, right? That's another key point. In a probabilistic reality, what you get when you make a measurement, what you get when you step into that woods, can be any one of many possibilities. You make a draw out of the probability distribution to pick one. And then after that, that's it. Once it's here, the information's here, it stays that way. You see, then somebody else walks in after you, they'll see the same thing you saw. But if we erase that information, no, it's a new game. We can start over again. Next guy walks in, there may not be a dead tree there. But see, he'll never know that there was one for the guy that got eaten by the bear. So it doesn't make any difference. There's no inconsistency left in the reality frame. You see, that's how the erasure experiment works. So we're seeing that the same rules that we applied to the double slit experiment work in the woods with dead trees, you see, but it works everywhere. When that astrophysicist looks through his telescope and he sees some part of the universe that's not been mapped before, he's seen a new part of the universe, what does he see? He sees what is probable. There's all kinds of things that might be there. So here's this big range of possibilities. And maybe out of that big bunch of possibilities, there may be 1,000 of them that are very similar in their probability. You know, they're almost equally probable. He's just going to get one of those. And after that, that's the way it is. You see, that's the way the virtual reality works. That's the way it is. And it stays that. And then from then on, you have to keep that in. You can't have that go away, have it different for somebody else. It has to be consistent. There's only a couple of rules here. One is you have to have historical consistency. And two, you have to abide by the rule set. You can't do anything that the rule set doesn't allow. And those two things are actually one thing. You have to abide by the rule set. The rule set actually enforces historical consistency. So those are the only issues. Now let's say this guy goes out of the woods. He sees the dead tree standing there. He goes out of the woods. He didn't really pay a whole lot of attention to that dead tree. He just looked in, and the dead tree wasn't all that interesting, so it didn't really make a big impression on him. He goes out of the woods, and he comes back 3 weeks later, and he walks into the woods. Does he have to see a dead tree? Not necessarily. It depends. Was that information? Is that information that dead tree existed really here or not? Well, that would be one of these, right? We're not quite sure. The system could play that either way. Depends. Because if there wasn't one there, he wouldn't say, oh, cheat, you know, there was a dead tree there before. How did it disappear? Because he wouldn't really know. He wouldn't miss it. So you see, it's like the information was perishable. So the information can be perishable. It doesn't have to be burnt to be erased. It can be just perishable that it can be erased. What about squirrels and bugs? What if there were squirrels living in that tree? Well, squirrels are conscious. I don't know about the bugs. Some bugs might be conscious. I know there's some bugs that are conscious. I've watched conscious bugs before, but you know, if you study bugs, you'll know that some of them do things on purpose. And you can see them making plans and doing things. It's not all just instinct. They make some decisions. But let's say there were squirrels in that tree, and those squirrels are conscious, and they lived in that dead wobbly tree. All right, now, would the guy walk in and see that wobbly tree? Sure, he'd have to, because there's squirrels there. He's already had a consciousness in that woods that had identified and defined that tree into existence. They're there. So he walks in, he has to see that tree because the squirrels are living in it. He can't walk into a woods and not see a tree the squirrels are living in because, you know, it doesn't exist for him, but it does for them. It doesn't work that way. We have to have one consistent virtual reality here that we all live in and we all share. Okay, so that's okay. But, of course, the man and the squirrel don't necessarily see the same woods. They see some of the same things, but a squirrel's view of the woods and a man's view of the woods are probably different. So the squirrel would only have made a measurement, right? Had the wave function collapse to a physical, you know, value for whatever the squirrel could see. The man could come in and he'd see other things, and the squirrel would see things the man didn't see and whatever. So it's a shared game. Now, consciousness, experiencing a virtual reality generated by consciousness. You see, that's what we have. It's designed to give you experience and feedback to facilitate entropy reduction, to facilitate your evolution. One major tenet here is that conscious intent changes the probability. Okay, this is an important one. Conscious intent changes the future probability. So if we have all these future probabilities that might happen, your conscious intent can modify that probability, can make it a little higher, make it a little lower. Okay, that's how we heal with our minds. We modify the probability of a future result. That's how the placebo effect works. Okay, the patient who's told this is wonderful medicine, even though he's getting sawdust, he's got this positive intent now. And this positive intent actually heals him. Makes him get better. Doesn't just make him think he's getting better, it actually heals him. It makes him get better. We know back in, I think it was 1956 or something, The Power of Positive Thinking, Norman Vincent Peale. Is that right? Yeah, and we all know that's true, right? If people who are positive and have positive ideas, they tend to get along better. Things work out for them. People who are negative, people who always, you know, are pessimistic and think the worst, you know, a lot of, you know, crap happens to them, right? They tend to have a lot of misery because that's what they're creating. But we not only can create that for ourselves, if you heal somebody else, you're changing the probability with your intent of their health. Okay? You know, I have a friend who says he creates parking spaces for himself. He goes into work where it's real busy and there's never any parking spaces, and before he leaves the house, he visualizes a parking space, and he holds that in his intent all the way as he drives in for 15 minutes or so. He has the car backing out just as he gets there, and he can pull in. It'd have to happen like that, because if the car backed out a minute before he got there, it'd be gone before he got there. So he has that visual that the car's pulling out and he pulls in. And if he does that, he says he gets about an 80%, he'll get a parking space. If he doesn't do that, it's about 10% that he gets a parking space. So people can do those kinds of things. You know, a lot of people will do that. You know, power of prayer, right? You've all heard of the law of attraction. You know, all of these things are use your intent to modify future probable database. The conscious system actively supports your evolutionary success. Okay, so you have a consciousness system. You're it, right? It's broken into its pieces. So you are this consciousness system. You're a piece of it. You're not all of it, but you're this piece of it. It's you and It's us. We're it. It wants us to evolve, lower our entropy, become love, because that way it doesn't die. You know, that's its survival mechanism, to evolve. So it can help us out, because lots of times, like I say, there's multiple solutions. A lot of times there's a dozen things that are almost the same probability. So the system can kind of nudge us. It's called synchronicity. Can kind of create something that just happens to put us at the right place at the right time, give us just the right information, the right connection. These synchronicities happen, and they happen because the system can work within the rule set. As long as it's one of those probabilities. And oh, what if they got this probability? Wouldn't that be cool? That would really give them a nice lesson. Well, why not? Because that's one of the possibilities, you know? So you can pull that one out. So that's how synchronicity works. Now, it doesn't mean everything that just happens to click with you is synchronicity. It's manipulated. It may not be. It may just be luck. But synchronicity is possible because there's multiple solutions to the problem of what abides by the rule set, what maintains historical consistency. You can meet those two rules with multiple solutions. The way the system can pick one that suits you. Okay. Who experiences synchronicities? Well, it's people who get something out of it. Most of your synchronicities, some of your synchronicities are just to help you out. You know, sometimes you get this message real clear and strong, duck. You know, and if you do, you know, something flies over your head, right? Some of them are just to help you out, but sometimes it's just to wake you up, just to show you reality is larger. And it's like, my God, how could that happen? What's the probability of those events putting me here just at that time when I needed to be here? And what that does is it wakes you up and say, maybe there's something bigger going on here than just, you know, randomness or us bumping around into each other. Maybe there's something larger. So a lot of it is just there as a wake-up call. So who doesn't get synchronicity? People who don't pay attention. People who the wake-up call wouldn't mean anything to them. They just say, oh, that's ridiculous. And they wouldn't see anything bigger. Well, there's no sense the system wasting its intents and resources where it doesn't do any good. So I had made the comment before that we create our own reality. We create it in several ways. 4 distinct ways. One, our behavior. Okay, if we're nice people, people tend to be nice to us. If we're users and abusers, people tend to avoid us and are not nice to us. So we make our own reality in that sense just by our behavior. That's obvious. The second thing is interpretation. We mentioned that. You get data, you interpret it according to your own data set, according to your own experience. And that may not be the intent of the sender or whatever, it's just your own unique thing. So you create your own reality by your interpretation. What somebody creates, somebody might interpret, somebody may interpret what you say to them as being hostile or being rude, but you had no idea that they would interpret it that way. That wasn't your intent, that was their interpretation of what you said, you see. So we all live in our own little realities. We all live in independent realities. Some aspects of it are shared, but because we interpret, our reality is based on our historical database, our own experience. Okay, a third way is the one I just discussed. Intent modifies the future probabilities. So you make your own reality by what you intend and what other people intend for you. That changes your reality too. But what you intend, again, positive thinking, negative thinking, that kind of stuff. Placebo effect, modify your reality with your intent. And finally, when we're talking about synchronicity, you modify your own reality because the system provides the opportunities you need to evolve. The system wants you to evolve. So if you put yourself on a path where intervention by the system will help you evolve, you'll get intervention by the system. Synchronicities and things will happen. If you put yourself on a path where that isn't going to do any good whatsoever, you don't. So you modify your reality by being ready, by being open, by being aware, you see. Then you get a different reality than if you're not open and not aware. So just by being aware. I have lots of people will read my books and say, that they got through, they're halfway through the book, and they started having out-of-body experiences. So all this weird stuff happened, synchronicities. I never had any of that happen to me, but I read your book and that happened. What's going on? Well, the only thing that's going on is they opened up. As they read the book, they said, oh, maybe there's some bigger possibilities here. And as soon as they opened themselves to the possibilities, they started noticing things. Things started to happen just by opening up to the possibility of it happening. All right. This gives a little bit of a cartoon about how these probabilities work. When I say you reach up in that distribution and you grab a probability, it's sort of like this. Here's a probability distribution like that. There's nothing there. There's a 1 above F, and E is 0, and G is 0. So if you're going to reach up into that probability, you're always going to get F, right? That's something that approximates objectivity. In other words, there's a little uncertainty there. You're always going to get something, in this little area. Very little uncertainty what you get out of that. Here's a probability distribution that's really broad. You reach up into this probability distribution, you could get an E, a D, or an F, or any of those things. There's multiple things that are all about equal probability. So this is what allows for anomalous behavior within a probabilistic reality, that you could get any of these sorts of things. So that's kind of the nature of these distributions. You reach up under the probability and grab out a value. Some probabilities are flat and some are very pointy. A false appearance of backward causality. There are a lot of backward causality experiments that you can read about. Go to the web and look up backwards causality. You'll find lots and lots of stuff there. The ones that I came across a long time ago, it's the earliest ones, I think, that started this backwards causality business, had to do with the health records. Since then, they've done it with more scientifically, if you will, cleaner, with radioactive sources and just random number generators. And we'll talk about that too, but let's just talk about this backwards causality. Matter of fact, we looked at a little backwards causality in that double slit experiment, didn't we? It appeared to be backwards causality, you see, but it's not really. It's what I said. It's not that those two spots turned into that diffraction pattern, that it changed. It was one and it changed to the other. That's the false appearance of backward causality. It didn't really. It just hadn't ever formed yet because nobody had looked at it. It was still in the probable future, you see. Still in the probable future. The measurement hadn't been made that brought it into this virtual reality. Okay, so let's do the hospital stays because they were first, so we'll give them credit. Assume that there's 20,000 patients. These are hospital records over 2 decades, say 20 years of hospital records. 20,000 of them. We're going to break these things into groups of, let's say, 1,000 each. So that's 20 groups of 1,000 each. Now, each one of these groups of 1,000 records each, and we've randomized them first, right? So they're all randomized. Each group of 1,000, we're going to break into 2 groups of 500. Now, we have just 500, so we know there's going to be, we don't expect those 2 groups to have exactly the same average hospital stay. They're not going to be exact, but they should be similar. I mean, they were just randomly picked, and there's groups of 500, and 500 is a pretty good number of samples. So we're going to have these groups, 20 groups, each broken into 500 each. Now what happened was, this was done in Israel. It was done by rabbis and a few other people who prayed or focused their intent or whatever. And they were praying for the health of these 500. The other 500 was the control group. This 500, we're going to pray for their good health. Now these records are old. These are people who've been out of the hospital a long time. So they did this, and then they looked at the average hospital stay in both groups. They found that the group that they had prayed for had a shorter hospital stay. That's backwards causality, you see. These are old records. How could they affect the health of people who've been out of the hospital for a decade or 2? So that was amazing, and they did it over and over again. Well, if you look at just that one, that's not really a big deal because they only affected it by a little bit. Okay? And you can have little bits of change. You didn't expect those two groups to have exactly the same average number of hospital stays. And the group that they had prayed for was, let's say, lower hospital stay by, a day or something like that, something small. Well, no big deal, right? Can happen. But then they did it in the next group, and they did it in the next group, and they did it in the next group. And what was a big deal was that I don't remember the number, but let's say 15 or 17 out of 20 groups, it was always the one they prayed for that had the lower number. Well, now that's like flipping a coin 17 times, getting heads every time, right? Because it should be just as likely that the group they picked had the higher number than the lower number, assuming they don't have equal numbers, which they wouldn't if you got enough decimal places. All right, so now it was something that was highly unusual and attracted some attention because they were able to consistently do it. Then they were having an effect. They'd flipped a coin 17 times and got heads. Well, maybe they flipped the coin 20 times and got 17 heads. The probability of that is very low. Okay, so this was when it first came to light that there was something going on with this. So they tried a couple of other experiments. One of them was that when they handed out these groups of 500 to the rabbis, they did the, let's say, repeat the experiment again. They had done the statistics on the two groups of 500, and they knew exactly what they were. They knew what they were. And now they were going to say, okay, Rabbi, see what you can do with these. And they couldn't do anything at all with them. It always turned out to be exactly what they had done, and they couldn't move any of them anywhere. They all were the same as they were. Why? Because the information was already here. You can't change the information, right? Once it's an electron through the slit, it's an electron. It doesn't suddenly turn into a rabbit or something else. It has to stay the same. So once it was measured, what are they doing? You see, they're changing the probable future, right? If you don't know what this data says, if you've never done the analysis of the statistics on this hospital data, you have no idea which one of these was higher or lower or whatever. It's all in the probable future. Intent modifies the probable future. So the intent was changing the outcome. It wasn't that anybody whose hospital record was in there got healthier. You were just modifying the data. In an objective world, of course, that can't happen. The data has to exactly represent what happened. Now we're saying the data doesn't really have to represent what happened. You see? Now they did the same experiment again with Geiger counters. Radioactive source, Geiger counter here, Geiger counter equal distance on the other side. When a radioactive source decays, it decays randomly in any direction. The particle can fly out in any direction. So it's equally likely to hit this detector as that detector. Let it run for long enough that you have 100,000 counts basically in both detectors. Take the data, save it, don't look at it. Keep doing a bunch of those, and it's just like hospital patients. People with their intent could make, say the right detector in all 20 cases have a little less or a little more counts, either way, than the other one. It's like flipping a coin 20 times, getting heads. They did it then with random number generators, the same thing. Columns of random numbers, break them up. Instead of 20,000 patients, 20,000 random numbers, break them up the same way. Reverse causality doesn't exist. Modifying the probable future for something that is still in the future does exist. That's how these experiments work. You've probably seen Bill Tiller on YouTube. He raises the pH of water and lowers the pH of water. So it's been around on YouTube a lot. If not, go to YouTube and look for Bill Tiller and pH or something, and you'll get it. He's a physicist, and he got a beaker of water out of a spigot, measures it. It's about 7, right? Neutral, like it should be. So then he gets somebody to sit across the room and try to raise or lower the pH of that water. And then he measures it, and then he lets him work for a while, and then he measures it and lets him work. Eventually, he can raise or lower that by like a whole pH. I think maybe sometimes it was like 2 pH. Well, if you know about a pH scale, you know that 1 whole pH is huge. We're not talking about, 0.1% here. We're talking about a huge change in the acidity or the alkalinity of the water. How does that work? Well, Bill Tiller has no idea. He just knows that he can do that. He can replicate that experiment. how it works is that the pH isn't a constant. When you measure that pH of the water, you're just measuring kind of an average value at that point of the measurement. The pH of that water, you could measure it in 50 different places in that beaker of water, and they all be a little different because those little ions in there are moving around. You know, water's breaking, you know, into components. You have OH minuses and H pluses recombining, pulling apart. It's a dynamic process that's going on all over the time. So the pH of that water on average is up and down, and you know, it's that kind of thing, right? It has a lot of variation in it. Little, but it's a lot of variation down at the third, fourth decimal place. So positive intent, what does it do? It takes the uncertainty. There's uncertainty in that pH because it's a variable, jumps up and down all the time. Within that uncertainty, you can raise it up to the degree of that uncertainty, the amount of uncertainty that's natural for that event. Just like the amount of uncertainty was natural between those two groups of 500 hospital stays. Those people weren't going to use their mind and make one group only stay an hour, where the average stay in the other group was 2 weeks. It can only work within the normal uncertainty of the system. And that comes out of a thing called the psi uncertainty principle. That's another thing we don't have time to talk about, but that psi uncertainty principle says that they can only make changes within what the natural uncertainty is, you see. So you can't make huge changes, and all he could do to change that pH was, let's say, where the variation is in the third decimal plate. Then he could change that third decimal place, you see. But then he could change it again and change it again and change it again, and eventually you can just walk it up. Change it 10 times, and now you're into the second decimal place. You know, change it 10 more times, and now you're into the first decimal place, and so on. So you work the thing up. It's because there's uncertainty there. Where there's uncertainty, there's probability. It's in the future. You can change the future probability. So that's the way reality works. It's just like the double slit experiment. There was uncertainty. Why is it that this idea that reality is probabilistic, why did it turn up first in a double slit experiment? Why is that where we really notice it? Because that's where there's lots of uncertainty. Little tiny fast particles zooming around, and we don't know where they are. So here's the size of the particle, and here's the size of the uncertainty around that particle. Okay? You get a rock, and here's the size of the rock, and here's the size of the uncertainty around that rock, just tiny. You see? So there's a difference. We see it in the little world because in the little world there's so much uncertainty. We don't see it with objects in the big world because there isn't. But now that guy walking into the woods, there was a lot of uncertainty there about what he'd find in the woods, wasn't there? Woods could be almost anything. Didn't have to be a dead tree there. Could have been all kinds of things there. So there was lots of uncertainty. So he picks one out of the distribution, like we showed you, and that's what you get. So see, there's lots of places in the macro world where there's lots of uncertainty. Uncertainty isn't just relegated to electrons and photons and things like that. Uncertainty can happen in this big world. It happens a lot, right? Happens a lot in your health, in your relationships to other people, whether or not you get the job or not, or get the promotion. There's lots of uncertainty. And all of that uncertainty is in the future, and it's all changeable with intent. Okay? We create our own reality, see? So that's the way these things work. Dr. Masaru Emoto freezes ice crystals, and he gets happy crystals and he gets sad crystals, right? He freezes crystals, and if he's a happy guy and he thinks happy thoughts, then the crystals are nice and symmetric and pretty. Then he thinks horrible thoughts and plays awful music, whatever, and then the crystals come out ugly and not symmetric at all. Well, what's going on there? Well, when water freezes and goes to crystals, there's a lot of uncertainty. You've ever heard that no two snowflakes are the same? That's because there's so much uncertainty the way those crystals form that you can get billions of different configurations. Lots of uncertainty. And intent modifies the future probability. It wasn't that water loves Beethoven and hates acid rock. It's that Dr. Emoto loves Beethoven and hates acid rock, or his staff, or whatever, So that's the active ingredient there is consciousness. It's not that the water has preferences to the music that it likes. See, that's the thing. We have what about fortune tellers? Similar kind of thing. What about somebody that reads tea leaves, tarot cards, chicken bones, astrology? How do all these things work? Well, these are all systems that have lots of uncertainty in them. When you throw those chicken bones, they can land almost any kind of way. Lots of uncertainty. When you drop those I Ching straws or whatever it is, or flip the coins and you pick up one to get your hexagrams, there's a lot of uncertainty there. Where you have uncertainty, you have the system and you both can change according to your intent. Okay, now with the hexagrams like the I Ching, then the system can use that uncertainty to produce some synchronicity, right? To have something fall out to give you a message it'd like to give you. That's called synchronicity. Okay, when you are telling somebody's fortune, then basically the uncertainty in the way those tea leaves look gives you something that can be interpreted many different ways. How do you interpret it? Well, if you're a good tea leaf reader, you interpret it because you're connected to that future probable database. What you're seeing is future probabilities. You get that information, and of course that's what your tea leaves are telling you. So it's not so much you're reading the tea leaves as you are getting the information and then out of that future probable database. That's where these prognostications come from. That's where the dreams, you sometimes have a dream and it comes true, right? Precognitive dreams. In your dream, you get into that future probable database. But it's only probability. Doesn't have to be just that way. Things can change. Intent can change it. Lots of things can change it. It's not a done deal, it's just probability. So let's take astrology. Again, with astrology, you have a very complex system that has a lot of uncertainty in how you interpret it. The astrologer is getting the data from the future probable database and fits that data to the uncertainties that allow her to interpret this in lots of different ways, interprets it in a way that fits the data. Now, how do you know that that's what's going on? If it wasn't that way, the very, very best, most accurate astrologers would be computers, because they can compute every heavenly body down to a nanometer, and they can do it, run forward in time, and they do it in a microsecond, and it's accurate, and it never makes a mistake. But we know that though people use computers to do horoscopes, they're only average. They're not really all that good. Why not? Why aren't they the best if they can do those calculations and if those interpretations are objective interpretations? Because that's not really what's going on. The key is that the astrologer is connecting, getting the information, using the uncertainty in their tools in order to tell their story. So that's the very best astrologers are astrologers who are very good at focusing their intent into the future probable database. And any astrologer, maybe some of you out here are astrologers, you know that you can't do good astrology readings if you're being annoyed, if you're being distracted. You need that quiet time. You need to get into what it is you're doing. As you're looking at all that data, you kind of get into a state that works for you. If you were trying to feed the baby and clean the kitchen at the time you were doing it, you probably wouldn't do very well. Well, that's because what you're doing is getting into a state that makes that connection. And you learn how to do that with practice, and you get good at it. So that's the way these things tend to work. I don't necessarily know that there isn't other aspects. I'm just saying this is one of the fundamental explanations of all those sorts of things. Whether they're tea leaves or chicken bones or however it is, they're just tools. Tools with enough uncertainty built into them that you can explain almost anything you want based on, they're general tools with a lot of uncertainty. So you get the data and then you can interpret it to fit. A couple of things. Here's an experiment. It's probably never been done, but it should be done. If you take the groups, let's say we're doing the radioactive decays this time, and we take the 2 radioactive decays of 500, and you, ahead of time, look at the average counts in both things for the whole group of 1,000. Okay, you take the group of 1,000, say what's the average number of decays or stay of hospital patients, whichever. Take that average. Then break it, then break it into the two groups of 500. Now let somebody use their intent to change one. Could they change it? Yeah, they could change it because you don't know which is in that one. You divided them up randomly. You don't know what it is. But what do you know? You know what the result is of the two. So that means if they change this one to a lower value, the other one has to go up to a higher value by the exact same amount, because we know that the two of them have to match to what's already the data in this reality frame. So that would be an experiment that could and should be done. Again, if you looked at the whole subset of the 20,000, you couldn't just, if you looked at that whole subset, or the whole superset of the 20,000 and knew what that average hospital stay was, then when you broke these other ones up, they'd still have to add up to that same value. So now you've just added another constraint. But let's say we'll do an eraser experiment. Let's say that the person took the hospital records, they had them all ready, they did the analysis on them, they know exactly what the hospital stay was for the average on every one of the groups, and that night the computer, or that night it caught on fire, building caught on fire and it burned all that up. The information's gone. So it goes back over to the computer in another building, generates the data again. Is this data now, would they be able to change it? Before they wouldn't have, because they'd done all the analysis on the data. But now they can, because that data's been erased. So see, it's back to the future. It was from the future into the present, back to the future when it got erased out of the... So all the things that happened in double slit happen here, in this world, just the same, in the macro world. So the same logic that drives quantum mechanics drives, talking to your plants, creating a parking place, intent-based healing, intent-based anything, power of positive thinking, law of attraction, all of those things. The reality starts out as probability until brought into this reality frame by an observation or measurement is a fundamental nature of reality, not something that only applies to small things. Summary. Now this is just a summary of this part. After this part, we're going to get into some of the everyday life stuff. And then after the everyday life stuff, I'm going to give you some what I call experiential exercises to help you learn how to create your own evidence that these sorts of things I'm telling you are true. Because I don't want you to believe me that they're true. I don't want you to disbelieve me that they're not true. Believing me or disbelieving me is irrelevant. It's not going to help you go anywhere important. It's not going to help you grow any. What you need to do is you need to convince yourself through your own experience. Has to be your experience. If it's not your experience, it's not your truth. If it's not your truth, it's a belief. If it's a belief, it's useless. It's worse than useless. It's a trap. Okay, so I keep telling everybody, go experiment, go figure it out, go learn. Well, I thought I'd need to show you how. So that's what we're going to do in the final session. Next, we're going to talk about life stuff, how this applies, really how MBT applies to your everyday life. And then we're going to do some exercises where we're going to teach you what I would call the minimalist set of how to heal and remote view. By the minimalist set is that we're going to throw away all the ritual and all the superfluous stuff and just do what's necessary and no more. And I know many of you do heal, and many of you have rituals and things that you do and processes you go through, and I'd like just you to bear with me and do it the way I say to do it this time and just see what happens. And those of you who have never done it, just do it this way and see what happens. I think you'll find it's easier than you think. So anyway, that's what's coming, and I guess here, in summary, you've seen that a big picture view of reality, a more complex physics, explains the subjective context as well as the objective facts of our existence. Because actually, all of our existence is subjective because our data stream, our interpretation of the data stream is subjective. There's very little in our life that's objective, and what we think is objective is only approximately objective some at a time, if the uncertainty is small. So reality is not objective. The scientific method is not always a useful process. Liberate yourself from the notion that it must validate everything. That objective proof is the only kind of proof there is. That's not the case. Statistical proof is just as valid, but it's not objective. It's statistical. In other words, how does a pharmaceutical decide that a pill is good? Say the pill fixes your headache. The way it decides that is it gives 1,000 people the pill who have headaches, and it sees how many of them their headache goes away, right? And if 50% of them's headache go away and the other 50% don't, well, it's, the pill may not be doing anything because, well, that might have happened anyway. But if 99% of the headaches went away within, an hour, then they feel like they've got something, okay? But who knows? That could have just happened anyway, too. So you see, statistical proofs are not objective proofs. They're a little different. That's like the difference between deductive logic and inductive logic. It's not quite the same. The objective proof is the deductive logic. So in any case, open-minded skepticism, I haven't mentioned that yet. The only way to get through any of this is with open-minded skepticism. Get rid of the fear, get rid of the ego, get rid of the belief. Believe nothing, and be open-minded to everything. Be skeptical of everything. Until it's your truth, until it's your experience, it's not your truth. So that's, I have to say that over and over because people have a tendency to jump to belief. Anything you read, anything you do, it's like, well, I believe it or not. So-and-so said something to me. Do I believe it or not? And we tend to jump to believe it or not because that's the kind of way we are. It's the ego. The ego wants to know. But the thing to do is say, well, maybe. I give that a 75% chance of being true, but I'll be skeptical, and we'll see if more data comes along. Living with uncertainty is key. You have to learn to live with uncertainty. These are some typical. NPMR is non-physical matter reality. That's any reality other than this virtual reality. I should even say any other virtual reality would be another way to say it. And as you can see by this list, these are just the things you all know about and heard about, things that you can experience. The key here is the very last, is the thing that's written in the yellow, that a low entropy consciousness can easily access all the above with a little effort, but none of it is necessary to evolve the quality of your consciousness. And I just want to make that point is that what it's about is becoming love and evolving, right? It's not about zipping through the non-physical, having cool experiences or reading futures or doing any of that sort of stuff. All of these things are there, and you can do those things, but that's really not the focus. The focus is growing up, becoming love. So we don't want to miss that up. Sometimes people get that cart before the horse. They want to go out and have out-of-body experiences, and they don't really concern themselves a whole lot with evolution of their consciousness. And if you get the cart in front of the horse, it just doesn't work very well. It's much better to worry about the evolution of your consciousness, grow up, get rid of that fear, get rid of that ego, and then if you're interested, do these sorts of things. But I recommend you do it in that order. It's just easier that way. You won't confuse yourself so much, and you won't get as frustrated. Can everybody do it? Yes. Anybody can do it. Anybody can grow up. It's what you're here for. Anybody can have these experiences. But it's like saying anybody can learn to, be a concert pianist. It's probably true. If you work hard enough at it, anybody could probably learn to do that. Maybe if you had very stubby fingers and were tone deaf, you'd be at a disadvantage. But most people could learn how to be a concert pianist, but they'd have to work at it. This is the same way. You can learn to do any of those phenomenal things if you like, or even grow up, but you need to work at it. It's not something that'll happen just because you want to. It's got to be something that you work in it. How? Well, I'd say first, start with meditation. If you don't know how to meditate, go to Google and on the free Google book, look up chapter 23 in book 1. It'll give you a nice explanation of how to meditate, what steps are to go through. Meditation is just a tool. Okay, don't think meditation is the end point or meditation is sacred in some sort. It's just a tool. And generally the way the tool works is it helps you get rid of the noise. Your consciousness, your awareness, unless you've worked on it for a while, is probably very noisy. That means it chatters all the time inside your head. You're always judging, you're always analyzing, you're always projecting into the future, worrying over the past, whatever. There's all this stuff going on all the time, and when you meditate, what you're really learning to do is to let that go. Put all that stuff aside, clear your mind so that none of that chatter is going on. And to do that, most of the way, there's lots of different meditation techniques. You can do it with breathing, you can do it with mantras, you can do it with visuals, mandalas, there's just hundreds of ways. You can listen to music, all sorts of ways to get in the meditation state. But almost all of them have the same technique, and that is fill your mind full of non-operative stuff, non-operative blather, if you will. Fill your mind full of something that kind of occupies your mind but doesn't give you anything to operate on. And if you do that, then eventually your mind's full so it doesn't buzz with all this stuff because you're always saying the mantra, or you're always focused on your breath, or you're always tracing the mandala with your eyes. Whatever it is you're doing, you see, it has the same thing. It's just like stuffing non-operative stuff in your head so that you're no longer thinking about things, analyzing things, judging things. That's what you need to shut off. You need to tell the ego to sit down and be quiet. Tell the intellect to sit down and be quiet. That's what you need to do. So that's the key, and the meditation just helps you learn a process to do that. The mantra that's a very popular one. You just say a word. The word shouldn't have any meaning to you. It ought to be a nonsense word. It ought to be a pleasant word, not something hard to say, and you just have that sound, and that sound just stays in your head, and because that sound's there and you're focused on the sound, then other things don't get in. When you kind of let that go and the noise starts again, you just gently put it aside, put the sound back in there. And it's the same with the breath. Just focus on your breath, and that's so boring that it's non-operative. So breath goes in and out, and pretty soon, you're meditating. So any of those things will work fine for you, visuals. But just practice at it. Eliminate fear, belief, ego, and expectations. That's the key. How do you do that? People ask me. The only antidote I know for fear is courage. Best way to eliminate a fear is to face it. So the best thing to do if you have a fear is to say, well, okay, what's the worst that can happen? What's the worst? My fear is if I go out of body, I'll die and won't be able to come back. Okay, my fear is whatever. So say, okay, I accept it. I'm going to try to go out of body and I just may die and never come back. That's the way it is. I'll deal with that. I accept it. It's okay. And then the fear's gone. If you can accept the worst, then basically the fear's had its fangs pulled. It can't do anything. So where you run into a fear, you combat it with courage. You have to deal with it and accept it. Struggling with your fear usually just makes it worse. Beliefs and ego, the way to work with those as well as with fears is just look at what you're doing, the motivation. It's not the act that's important, it's the motivation. Look at your intent. Everything you do, every little thing, the way you react to somebody, the way you talk to your parents, the way you talk to your children, the way you treat your neighbors, just every little thing, the people that you work with, how you interact. It's really about interaction and people mostly. How do you do that? What's your motivation? You trying to manipulate them? You trying to get them to do something you want? Are you worried that they may manipulate you and get you to do what they want? I mean, what's going on? What's your real motivation in dealing with people? And then if you see that that motivation has something to do with fear or belief or ego, then cut it out. Just don't do that. Don't go there. Try to make yourself notice it, because noticing it is a big part of the problem. We're full of fears. We're full of ego, and we don't notice it. These are things that are outside of our intellect. A lot of them are just cultural. It's the way you get it by osmosis through the culture. So just inspect every detail, and you can do that best by living in the present moment. If you're just aware in the present moment, you're not concerned about past or future. You're just aware of what's going on, of every interaction, what you're saying, why you're saying it, what's going on here. Just be aware of it rather than just do it like a zombie like most of us do. You know, we just go through life, we say what we say, we do what we do, and never think a thought about it. Well, be aware with it. Be plugged into it. What am I doing here? Why am I doing it? And if you do that for a while, you'll find all kinds of fear and ego that'll just pop out, and it'll surprise you what you find, and then just start putting it aside, getting rid of it. That's the key there. If you want to have an ego meter, one of them is you can count how many sentences you start with I. How many sentences you start with I and me. Because sentences that start that way generally are about you. And if you're mainly talking about you most of the time, that's probably a sign that you get more ego than you need. So that's one way to look at it. Another way to look at it is how fulfilled, happy is kind of a broad word, content, how much peace do you find in your life, all those kinds of things. If you're kind of low on those quantities, then it's probably because you have more fear and ego than you need. So once you get rid of the fear and ego, you'll find your life is a lot more pleasant. It's a lot more positive. It's a lot happier. It's more, there is more peace and satisfaction in whatever it is you do, and a lot less anxiety and a lot less frustration. So that's another measurement that'll tell you how well you're doing. So it's just something you have to work at. If you don't work at it, then nothing will happen like anything else. Okay. Approach to meditation. It's interesting if you look at the slide. Look at all the things that are in yellow, because those are all the key things to do. And see, they're all about what don't do. None of these tell you what to do. That's because meditation is natural state. It's as natural as breathing. You just do it if you can get out of the way. So what's important is that you fear nothing, hope for nothing, no thinking, no analysis, no judging, expect nothing, eliminate beliefs, don't compare, don't judge. It's all the things to stop doing. And if you can stop doing all those things, you'll be in a meditation state. If you're quiet and just kind of being by yourself. It's all those things that you have to quit. So meditation is not a new thing to learn how to do. It's a bunch of old things to learn how to not do. Okay. Only you are responsible for who and what you are, and only you can change that result. Okay, our intent influences the probable future. We talked about that, and that's why fear, ego, and beliefs end up creating struggle and pain, and why love, compassion, and caring about others tends to generate peace and satisfaction, because you create these realities. If you're full of anxiety, you create a reality full of frustration and things that aren't working the way you want them to work. Perhaps the problem is they have to work the way you want them to work might be the problem rather than actually the way they're working. So that's a point. Remember, the placebo effect and the quality of your personal interaction with others is real medicine. You affect other people. It's not just you in a vacuum. You have to think of yourself as entangled with everybody else. So think of yourself that way. It's not just you in a vacuum. You affect everybody you interact with, and they affect everybody they interact with. So when you are very positive, it helps create a positive environment around yourself. When you're negative, it helps create a negative environment. When you have a lot of ego, it helps create ego in others around you. So you have to be aware of that. In a probabilistic reality, almost anything can happen, and often does. Always remain skeptical and open-minded. We talked about creating your own reality by your behavior, interpretation of the data. Intent modifies future probability, and you get the opportunities you need and can use to help you grow up. Morality attaches to intent, not to action. That's another result of this MBT theory, is that it derives what's moral, what's right and what's wrong. Now, there's been philosophers trying to produce moral codes for centuries, and generally they always run afoul. It never seems to work out because there's always exceptions, and they say, well, this is moral, and then there's some exception where it's immoral, and vice versa. That's because they're trying to specify the morality of actions. Actions don't carry moral value. Intent carries moral value. For instance, somebody's walking ahead of you and you see a $20 bill fall out of their back pocket and lay on the ground. Okay, now what are you going to do? Let's say you do the exact same thing in the exact same way, but you do it for two different motivations. The first motivation is, oh, they lost that $20 bill, I need to give it back. So you run, you grab a $20 bill, tap them on the shoulder and say, here, you lost this. And they say thank you and so on. The second one, you see the $20, you notice that there's all sorts of people around and that they're watching you. They see you and they see that $20 bill, and the only reason you're going to give it back is because you know some of those people and you don't want them to know that you stole somebody's $20 and didn't give it back. So you pick it up and you run up and you tap them on the shoulder and you give it back to them, you see. It's the same thing. One of them was a moral act, the other one wasn't. One of them was an act out of caring, the other was an act out of fear, you see. So same action can produce, you know, evolution or non-evolution, even if you do the exact same thing. So what carries moral consequences is your intent. Why you do what you do, what you're intending to do. And sometimes if you're intending to do something good, it may not work out and it may not do a whole lot of good. Well, if your intent was good, that's okay. You did the best you could. So, and you may intend to do something bad and it turns out it works out pretty good, but you don't get any points for that, you see. So that's important. In general, the way that works, if whatever you intend helps the system, not just yourself, but helps the system to decrease its entropy, it's good, it's moral. Anything that you would, any intent that you might have that will help the system, increase its entropy and de-evolve is not good. So we're going to base the system on this, on our morality, on the same way that we decide whether we're evolving or de-evolving. If we're in the process of whatever we're doing and intending and it's part of our evolution, it's good. If it's not, if it's part of our de-evolution and we're dragging the system down, then it's bad. So that's an easy moral thing. And it's not just you, I say the system, because you can do something that is good for you, but hurts a lot of other people. That's not good. It's good. It has to be, the net gain for the whole system has to be a lower entropy. It has to move it toward love. You have to move yourself toward love. All right, we've talked to this a little bit already. Just a couple of things I want to emphasize. If your motivation for being here is to decide whether or not you should believe or disbelieve what I say, you're approaching the problem incorrectly. If you're looking for me to give you objective physical proof of the non-physical, you're wasting your time. On the other hand, can I help you experience psi phenomena for yourself so that you can come to your own conclusions? Yes, of course I can. Can I teach you how to affect physical things with your mind? Yes, I can do that. Can you absolutely, objectively, and conclusively prove the reality of these experiences to yourself? Of course you can. Will your experience serve as objective proof for anyone else? No, never. Okay. All right. Love. All love is non-conditional. If there are conditions, it's not love. We tend to confuse love and need. We talk about, in our culture, we tend to talk about falling in love. That does happen occasionally, but mostly we fall in need. We find somebody that meets our needs, and we meet their needs. And the relationship goes on based on needs, and then it gets into trouble when needs change or when ability to meet needs change. You see, love doesn't have that. Love doesn't take two. Love can be done by one. Satisfying needs has to be done by two, right? That's a relationship thing. But love is non-conditional. Sometimes I get people who say, but if it's all about love and all I do, I'm just positive and I love everybody and I care for everybody, aren't I going to get abused? Aren't I going to be everyone's doormat? Well, what are you here talking? Fear, right? That's fear talking and ego talking. It's fear that you're afraid you're going to get abused, and it's ego, oh yeah, but what about me if I get abused? You see? So right away, that's an approach to a problem. That's the wrong approach. It's just the opposite. You see, it's not, you won't be the doormat. It's not about what you get out of the relationship. Without fear or ego, you see, it's about giving, not taking. And you want people to find advantage and value in what you give them. See, now that's the opposite viewpoint, you see. Now you're approaching it from the other way. You have to give without the thought of getting in return. And that doesn't make you a doormat or a sucker. It makes you whole. It makes you valuable. It connects you in a very positive way to other people. It gives you purpose beyond the care and feeding of your ego. It gives you credibility and earns trust, which gives you the power to influence, to help, and to be useful. If we think of the people in history who have been powerful, if I think of powerful people in history, I think of people like, well, we're in Atlanta, like Martin Luther King, right? He changed the attitude of a whole nation. That's a hard thing to do. And he did that because he had the philosophy of we're all brothers, right? It wasn't black against white, or it wasn't that kind of a thing. It was we're all brothers. We're all human beings. We need to treat each other like that. We need to treat each other better. Because he was approaching the problem with love, he had a huge effect on his culture. And that effect still is rolling on today. It's not like that went away. But the effect and the change that he created in our society over a 10-year period or a 5-year period, still growing, still at work today. Gandhi had a major effect, ran the British out of India. Sorry, Keith. And he accomplished that entirely peacefully. Nobody got shot, nobody died, and here was those who were second-class citizens got their country back. And they've done well with it. India's doing pretty well with that independence to this point. But he did it because he didn't use violence. You see, that made him very, very powerful. And again, we have good that's lasted a long time. And then people bring up somebody like Hitler and say, look how powerful Hitler was. But look at that, how powerful he was. First off, what did he do today? Where is his continuing legacy? Well, it didn't last long, did it? Shortly after he was gone, things he did were undone. The things things he had started were stopped. There is no lasting thing. His power was all physical. It wasn't real power. Well, it was if you're physical, right? I mean, if it hurts your physical body, then I guess that's a power. But that's not the power I'm talking about. The power of love is a much stronger and much more lasting and much more effective and much more valuable power than the power of control and force. Control and force, everybody resents, and they'll either get rid of you or be awfully glad when somebody else does. Control, power, and force tends to be self-destructive. That's why totalitarian governments are unstable, because nobody likes it. It doesn't last very long. It may last 10 or 20 or 50 years, but that's it. They go away. They don't last that long. So that's an unstable form of government. It doesn't have its power is all superficial and short term. There's no imperative in this philosophy to be a pacifist. There is an imperative to respect the free will of others and to always act with good intent, to act without fear, to act with no ego. However, if others do not respect your free will or the free will of those under your protection, like your children, say, your young children, you may resist or, if necessary, fight. This is not a pacifist philosophy. But that almost never happens. There's almost always another way to solve a problem before you get to the point where you have to use violence or force or control to solve that problem. You should find very, very few of your problems having to be solved that way, whether they're personal problems or some other kinds of problems. There's always, I shouldn't say always, sometimes there's not, but most of the time there's a better solution. So those should be very, very unusual. With caring about others, you gain real power, satisfaction, and growth rather than the temporary empty power of dominance and force.